Hello and welcome to part 2 of the videos. Question 3. It says we have a steel girder, there it is, with some forces acting, with some ropes holding it or some wires holding it or something, and it wants you to find the horizontal component of the tension in each cable. So there's our tension, and we've got a horizontal and a vertical component. Well, the horizontal component, okay, is going to be, it says the tension T in each cable is 850 newtons. The horizontal component is going to be 42 cos 42 times the tension. Okay, so it's going to be 850 times cos 42, 650 newtons. Vertical, on the other hand, of course, is going to be sine 42, so that comes to 570 newtons. Now, question 3 wants you to find the weight of the girder. Simply analysing this situation, the vertical forces up from the two cables must equal the weight going down. Therefore, 2 times by the tension, the vertical tension, let's just say TV for vertical or something, is equal to mg. And of course, we said the vertical tension, the vertical force up is 570. So it's 2 times 570. So we've got 570 up there, 570 up there. Those are your two forces upwards, which is 1,140. That must therefore be the downward force. Now, of course, that's only 1100 to 2 sig fig. I'm just being precise in this place. All right. 3b. Describe the line of action of the weight of the girder. Well, it's going to be acting straight down the middle, assuming it is a uniform girder. And this is the key word over here. You can't see it, it's not on the screen. This is your key word over here. It's a uniform steel girder. Subtle word, means a great deal. Okay, it means that this thing has a uniform thickness and density, therefore its centre of mass and centre of gravity is slap down the middle. Okay, that's that. Right, question 4. Define the moment of force. Now, people, I've got to say this to you, can't say it enough. The definitions are key to this course. They are money for jam. They are easy peasy. You just go out and learn it properly, and then you spit it out on a piece of paper on the day of the exam, and you get 2 marks for basically just memorising a sentence. It could not be easier. So, the moment of a force is the product of the force and the perpendicular distance from its line of action. There are 4 key words in that, and you have to have all 4 of them in there. It's a 2-mark question, and you have to have all 4 of them in there to get your 2 marks. So basically, as you just said, force times distance is 1. If you said product of force times perpendicular distance, you get the other one. And it's so many people will lose 1 mark on something that's so easy, and if you do that 10 times, 10 little simple things, you're going to slip a grade boundary. So make sure you don't do it. Right, 4b, moving on. It wants to know the moment of the force about O is 4.6 newtons. Calculate the value of the force. Well, we know the moment is the force times the perpendicular distance. We know the moment is 46. We don't know what the force is, but we know the perpendicular distance must be this distance here. Well, if that is 0.25 and that is 40, this must be cos of 40. So this is 0.25 cos 40. It's just trigonometry. Solving through for that gives us a force of 240 newtons. Now, describe how the force changes as the pedal moves through 80 degrees from the position shown. Well, 80 degrees from the position shown, it's up at 40 degrees there, so it's going to go through to horizontal and then down to there. So basically, the force changes, the horizontal distance changes. Its maximum in the crank arm is horizontal. I've put a 0 in the crank arm as vertical, which is stupid because it's not going to get vertical. So it's going to be less, excuse me, when the crank arm is 40 degrees below horizontal. There you go. Even people like me don't read the question properly sometimes. So it's going to do 80 degrees from 40 through to minus 40. So it's going to reach a maximum and then go back down to, well, it's actually going to go back to exactly what it is here, 46. Okay, so it'll go to a max when the crank arm is horizontal, less when the crank arm is 40 below 0, 40 degrees below horizontal, and we could even be even more precise and say it'll be 46 Newton meters again, because it's the same angle above as it is below. There we go. That's question 3 and 4.